Okay, so for this lesson, we are going to be simplifying radicals. So remember what that means from our last video. When we're simplifying radicals, all we're doing is simplifying exponents that are fractions, okay? Radicals are just a different way to write a fractional exponent, okay? So we call it a different notation. Notation is just how I write it. So here, let's look at a radical, and let's look at the parts so that we can have the terminology down. This little guy, the little house looking, check mark house looking guy, almost looks like the long division symbol, but it's not. It's got this little check mark. Okay, this is called the radical. Okay, not that it's super important, this name, but this is called the radicand. It's a silly name. Anyway, I won't ever say that word again in my life. And then there's another part to a radical that you may or may not see, okay? So before I showed you the square root of x, okay? And so you have the radical, and then you have the number inside of there, or the value inside of there. There's a possibility that you might see something like this, okay? And what does that little 3 mean? Well, we call that number the index, okay? And it has to do with, so when you have a radical, all right, it is assumed that we are taking x to the 1/2 power, okay? That means the same as x to the 1/2. So what if I wanted to write x to the 1/3? How do I use that, write that using a radical? Just like this, x to the 1/3, okay? If I want to write x to the 1/3, okay, I need to put a little 3 inside of that little, inside of my check mark, okay? So we won't really work with this too much. We're gonna stick with just a square root, raising x to a 1/2 power, but you could do this with as many as you want. You could say to the 10th, okay? That would be x to the 1/10 power, okay? So here's the deal. If you don't see a number inside of your check mark, it's understood or it's assumed that your index, the n, is 2, okay? See how you would have a 2 right there? So it's not necessary to write the 2 because when we communicate the square root of x, if you don't write a number there, I'm gonna assume that it's the square root, okay? We would call this the cube root. We would call this the 10th root, all right? So there's different names for it. We're going to be sticking with pretty much square roots, okay? Now, what's gonna help you complete this work in our binders, and I'll attach it to have it attached to the assignment, but on the green sheet at the beginning, okay, on the green sheet, it's a list of all the perfect squares, okay? We call them perfect squares, because you can take the square root of it and it gives you a whole number. So what are some perfect squares? So when we do a square root, so let's say I have the square root, and I'm just gonna write it off to the side as an example, the square root of 9. What does that mean? What operation is that, okay? The square root is an operation, so it's telling you to do something. What is it telling you to do? You need to find the number that when you multiply that number by itself, you get the number 9, okay? So what times what gives you 9? Well, 3 times 3 gives you 9. So the square root of 9 is 3, okay? Let's do another one. What about the square root of 16? What number times itself gives you 16? 4. The square root of 16 is 4 because 4 times 4 is 16, okay? So we have a whole list of perfect squares. 4 is a perfect square. Why is 4 a perfect square? Because 2 times 2 is 4, all right? 9 is a perfect square. Why is 9 a perfect square? Because 3 times 3 is 9, okay? 16 is a perfect square because 4 times 4 is 16. 25 is a perfect square because 5 times 5 is 25. What would be my next one? 36, 49, 64, 81, 100. This can go on and on and on and on and on. And you can see that on your notes, okay, on that green sheet of paper. You can see all of these. So if I take the square root of 4, it's 2. The square root of 25 is 5. The square root of 64 is 8, okay? One note that they put right here is that the radical also serves another purpose of communication. I say the square root of 16 equals what? Well, you ask yourself, what number times itself gives you 16? But not only that, you have to ask yourself what positive number, okay? The square root acts as almost an absolute value, like it needs it to be positive. Because the fact of the matter is, if I just ask you what number times itself equals 16, you could have also said -4, right? Because -4 times -4 equals positive 16. Why did I not write -4? Why was that not part of the answer? Well, because this square root guy right here, it also enforces you to make a positive number, okay? And we'll see that in our next section, or 2 sections from now. We'll have to see that again. We'll have to come about that. So the square root means positive, all right, just so that we're aware.